Okay, so for number 3, we want to find the domain. Now, this is the problem that's on your sample, but I also created 2 other examples for you because you want to make sure you understand how to do all 3 of these different derivations because they have a little bit different way that you approach each of these problems. So I want to make sure you understand how to do all 3 of these, and for the test, one of these type is going to be on the exam. Let's talk about this one first. Now, domain, what does it mean? Domain is all the numbers, all the x values that make it the function defined. So all x values that make the function defined. That means you cannot have division by 0 or square roots of negative numbers. If any of those type of situations happen on these problems, then those numbers cannot be included in the domain. So we're basically finding what values will make it work. What numbers, if I plug them in here, will I get something defined. So let's take a look at the first example here. I got square root of 7x minus 3. Now whenever you see a square root, that means that you're going to have an inequality as part of that because it's talking about numbers that will make that positive on the inside is what you're looking for. But at the same time, we also have a square root that's on the bottom of the fraction, which means it's possible we could have division by 0 happening. So we have to deal with both the situations on this problem. What you're going to do is you're going to take 7x minus 3, and we're going to set it to be greater than but not equal to 0. We don't want to put the equal sign here because we don't want this to actually equal 0, because square root of 0 is 0, then you have division by 0 happening. So you don't want to have that. But at the same time, we also have this inequality here. Now the reason why we have greater than 0 and why it's always going to be the greater than symbol is because we're looking for the numbers that make the inside of that positive. We're only looking for positive numbers, and this is how you would express that as positive numbers. Greater than, but we're not including the equal sign. We don't want it to equal 0 on the bottom because then you have division by 0. So this is the correct setup if you've got a square root on the bottom of your fraction. Let's solve it. We're going to do 7x, add 3 to both sides. So we get that, divide both sides by 7, you get x is greater than 3/7. You have to express your answer in interval notation. You'll have to do that on the actual test as well. So if we do interval notation for that one, 3/7 is going to be a parenthesis. We don't want to include the 3/7 because again you have division by 0. So that would be your final answer, 3/7 to infinity. Greater than means you're going to positive infinity. Now next, we don't have an inequality on the second one here, but we still have to deal with division by 0 happening. So this one we're not going to have an inequality. We're not going to have greater than or less than because you've got just that on the bottom. So anytime you have just a regular expression with x in the bottom, here's what you're going to do. You're going to go ahead and do x squared minus 4 is not equal to 0. Whatever's in the bottom cannot be equal to 0 because we can't divide by 0. That's undefined. So we're going to set it up this way. And we'll factor this next, difference of squares. And then each one of these we'll go ahead and set up with not equal to 0. So x plus 2 not equal to 0, x minus 2 not equal to 0. And if you set it up and solve, you get x is not equal to negative 2, x is not equal to 2. Okay, so basically what we solved for is we found the 2 numbers that are not allowed to be put into here. If I plug in negative 2 into here or 2 into there, I get a 0 on the bottom and I can't divide by 0. So my domain is going to have to be all numbers except for these 2 numbers. So we have to write this out with interval notation. Now for interval notation, what we're going to do is we're going to include all the numbers less than negative 2 in between these 2 numbers and greater than 2. So I'm going to do negative infinity to negative 2, negative 2 to 2, and 2 to infinity. Okay. Now the most common mistake that I usually see on the test is because I've showed you this example with 3 intervals on there, then somehow students think that we got to have 3 intervals in the actual test. That's not always the case. It has to do with what expression you have in the bottom. If a square wasn't there and you just had x plus 1 over x minus 4, then there would only be 1 number that would not be included. In that case, you'd only have 2 intervals. So it has to do with the numbers that you solve for. So don't just try and memorize this and think, oh, there's 3 intervals, I got to have 3 intervals in the test. You have to actually solve it and see what numbers are not included. So here you've got negative 2 and 2. The idea with the sample is you want to actually look at different variations, but you want to do all the different variations so you understand the concept. We're not talking about trying to memorize numbers here on these kind of problems. Okay, so for that one, we're not including negative 2 and 2. Now for the last one, we do have a square root again, which means that you're going to be using inequality. Now this particular one, the square root happens to be on the top of a fraction. And we do have something on the bottom here, but notice that the bottom is a 6. Now, that 6 can never be equal to 0. So if you don't have a variable in the bottom of the fraction, then you don't have to worry about it. We don't have to set that equal to 0 because we know it'll never be equal to 0. The only time we have to deal with the bottom is like these problems where you have a variable in the denominator. In this case, you just have a 6. So it's okay just to go ahead and ignore that. And we're going to look at the top one. So you have an inequality on top. So this time, what I'm going to do is I'm going to use the greater than or equal to symbol. We're going to include the equal sign this time because if I have 0 on the top of a fraction, that's okay. 0 divided by 6 is 0. The only time that was a problem was this one over here where you're dividing by 0. So notice the difference here. If you have a square root on the bottom of the fraction, you're going to use a greater than symbol. If it's on the top of a fraction, you're going to use the greater than or equal to symbol, which means that we're now going to include that one. So no equal sign here, but we do have it in this one. Let's solve now for x. We're going to subtract 2 from both sides. So subtract 2, get negative x greater than or equal to negative 2. Now there's a negative 1 that's in front of there, so if we want to solve for x, you have to divide both sides by negative 1. Now when you do that, whenever you multiply or divide an inequality by a negative, like what I'm doing here, your sign is going to switch. Okay, so your sign switches directions. That only occurs when you're multiplying or dividing by a negative is when that occurs. So I'm dividing by a negative here, so the sign switches. So I have x less than 2, which means that my interval will be this. It's going to be from negative infinity to 2, and I got to put a bracket on that because I have the equal sign that I have on this one. So equal sign all the way down because, again, if I put 2 into here, I get square root of 0, which is 0. 0 divided by 6 is still 0. That's okay. So for this is my final answer, negative infinity. We are including the 2. So make sure you understand how to do all 3 of these variations for the test.